Hello and welcome everyone. So I'll be explaining recent Codeforces round 768 division 2 problem B, fun with even subarrays. Basically, in this problem you're given an array with n elements and you could follow some operations to that array any number of times. What you have to do is find out the minimum number of that particular operation in order to make all the elements equal. All the elements of that array equal. Now, the question would be, what is the operation that we can do such that we could make all the elements of the array equal? That operation, I'm going to explain you. It's actually difficult here to understand. Rather, I would explain you with by giving an example. Let's say that okay, let's take this this array here, where we have every element that are distinct. Now the operation is, you could choose any subarray, any length of subarray, and what you can do is, okay, let's see. Okay, yeah, that's it. Okay, so basically what you have to do is, you could pick any subarray you want, and let's say I pick this subarray 5 6 7. Now what I can do is, I could now what is the length of this subarray? It's 3, right? Now what they've told us is, what I can do is, okay, if the length of the subarray is 3, I could just drag this part. Imagine, just carefully see what I'm trying to do here. I could drag this whole, I could depict this part as a pillar of these values, let's say, and what I could do is simply pick that pillar and move here like that, by making this value as 5, this value as 6, and this value here as 7, such that it makes something like that, 5 6 7 and 5 6 7. I hope you're getting what I'm trying to say here. That's exactly what they're trying to do. I'm just explaining it in a layman's term. Okay, now that's exactly what they've told us, what we could do in a particular operation. Now the objective, what is our goal? Our goal is to make each and every element equal of this array. Now we cannot just pick a subarray with distinct elements, such because if we do an operation, it's ultimately going to result a part where values are distinct. So instead, the best way to do that, of course, we have to pick a subarray, which is where every elements are equal. Now the question is, where do we start to find that subarray? This is the big question. And now I'm gonna make a claim, which is, I'm gonna start to find out equal element of subarray from the back of the array. Why is that? Because first of all, I need to make all the elements equal. Now in order to make all the elements equal, what the operations actually were doing, it was actually assigning these values. If I take, let's say 5 6 7, okay, this subarray as an example, what was it doing? It was assigning this value here, it was assigning this value here. Remember the direction, it's going from right to left. Similarly, 7 going from here to here, and making these values equal to respectively 5 6 and 7. I hope you're understanding. So like, the direction of the operation is moving from right to the left. So it's obvious that if I'm gonna try from the back of the array, because I don't have anyone to color the back element's value, because there's no one right after the back value or the end of the value. Take a look at it. For example, in this array, there is no element here presenting here after the value 7 in this index. So it's obvious to start from the back of the array. That's exactly what we're going to have to do. Now, how is this going to roll up? Let's take our array was like this: 2, 3, 4, 5, 6, 7. Okay. What we've told, what I said, I'm gonna start from the back. I'm gonna start traversing from the back. Now this is my subarray with equal elements. Every elements are equal of 7, right? Now if I make an operation, what's gonna happen? Okay, the length was 1. 1 times 2 is 2, meaning I'm gonna take this pillar and I'm gonna move it to here, meaning it's gonna make this 6 equal to 7, thus resulting a length of 2 length of subarray with equal elements of 7. Now what we have a length of 2. How far we can move? We can move till 2 times 2, 4, resulting a 4 length of subarray of equal elements. How is that? If I take this pillar and I move it here, this becomes 7, this becomes 7, making it 7, 7, and making it a 4 length of subarray. Similarly, from 4 till 4 times 2 equal to 8, 8 times 2 equal to 16, and so on and so forth, and traversing it from the back until we make every element equal of this array. That's exactly how we're going to traverse. But another thing that we need to notice is, let's say the array could be something like that, where as I've told you, I'm going to traverse it from the back. Now if I traverse from the back, I'm seeing that I will always try to find out the longest subarray from the back where each and every elements are equal. Not just one element. I'm going to try to make the longest subarray, and then I'm going to try to traverse that. That will be easier for us to implement further. So from the back of the array, I know that this was the farthest that I can go now. Now I can make a move and make my subarray operation, which is, as the length is equal to 2, 2 times 2 is 4. So resulting subarray with equal elements will be 4. By making this pillar moving to here and making it 2 and 2. Now take a look at it. If I make 2 and 2 here, what is happening here actually? Think about it. What is happening if I make this here? If I like swap this with 2 and 2, I'm not actually getting 4 length of subarray. It might happen that there are some equal values which are further, but inside there is a gap between them, meaning that back value could be some further from the back, but I don't know that yet. So I have to check for that, and thus it will save our time. And I can see that after making those 3 and 3 equal to 2 and 2, I'm actually not only getting 2 times 2, 4. Instead of getting 2 times 2, 4 length subarray, I'm getting 1, 2, 3, 4, 5, 6, 7 length subarray. 7 length subarray. Now, so my goal would always be to find the first element where the indices values are different, and thus making all the values from that till the rest equal to the back value, like that. Now the current situation is that I've got 7 values, which are 2 from the back with the subarray. Now I can easily make a claim and make the operation 7 times 2, meaning 14, which is already crossing the array, I guess. If I pick this pillar of 2 of elements equal to 2, of 7 elements equal to 2, and if I put this pillar right here, it actually not only covers the whole array, it actually crosses the whole thing, and thus making every element equal to 2. So that's exactly what we're going to be doing on this problem. I hope I could make you understand. I hope I did make you understand that. Now let's jump into the code part. Okay, there you go. The code part here, it's not that complicated. Okay, first we're taking the elements here, and this was the longest subarray from the back, where each and every elements are equal. This is exactly what we're talking about when we're finding the like this part, discussing that example. When this was 3 and 3 and this was 2 2. So like, hope you get that. Now like the first, after that, inside the while loop, always jumping to always taking a measure of the maximum subarray till we got to, and after here like decreasing the values from starting position. Initially the starting position would be the first position where like last position from the back, where each and every element were equal, and that was running on. And as I'm actually traversing from the back, that's why here decreasing with the maximum length of the subarray. And after that, I'm gonna multiply it by 2. As I've told you, I'm gonna take that pillar and I'm gonna move it to the left from right, and that was like, that's gonna count one operation. And this is the part where if some of the back elements appearing in front of the array from the back. So I hope you're getting what I'm trying to make you understand. They're equal, these two elements here, and if they're equal, like if the back element appears somewhere further from the back, and in between them some other values may appear, but when we reach at the point where that value again appears, that back value, that's when we need to work on this while loop, and that starting position gets decreases without adding the operation, because the elements were already there. We didn't need to insert those elements following the operation. So yeah, I hope you understood what I tried to make, and yeah, till next time, goodbye.